Hello, my name is Peter Bassett, representing the Astronomy Roadshow Mobile Planetarium. Well, the lesson for today is all about the Sun and our relationships with it. So the Sun, as we know, is our own star, but we haven't always known that, of course. It did take time to actually realise that. And the first lady to actually appreciate the Sun was a star was Wilhelmina Fleming. She was born in 1857 in Scotland, and then she moved to America and studied at university there, in actually Boston. Okay, she analysed light from stars with a telescope and realised the same type of light coming from the Sun. And so through a little bit of chemistry, a little bit of physics, she worked out what the Sun actually was and confirmed that it was a star. Okay. Anyway, that was confirmed in about 1890 or so. Right, anyway, the Sun of course illuminates space. It comes out in all directions. Light travels outward in straight lines, generally speaking. And of course some of it reaches the Earth. So if we line up the UK, there we are, so we're in daylight at the moment, so there we are. And anyway, the Sun illuminates this side of the Earth at the moment, but of course light can't pass through the Earth. It is opaque, so therefore it's got a shadow behind us going back this way. Anyway, so this part is obviously the Earth's night at the moment. And if you want to time the rotation of the Earth, what we normally do, we take it from midday. Alright, we start a stopwatch up and we carry on waiting until the UK is back here again, facing the Sun again, and that's 24 hours. That's how we take the times. Okay. It's not actually midnight to midnight. That's when we change the date itself. Alright. Anyway, re-rotating 24 hours like this, and the Moon is orbiting us. This where it does get a bit complicated. The orbit itself, if we keep the Earth still, the Moon travels around us in 27 days. Of course, it's not still. It's orbiting with the Sun at the same time to make it more complicated. So we now add the two motions together. So there goes the Moon. And the Earth's doing that, and 27 days later the Moon's lined up with the Earth again. Alright, that's fair enough. But the thing is though, it's not lined up the Sun yet. That takes 2 more days for that to happen. So it's 29 days to line up the Sun, 27 to line up with the Earth. So which one do you choose? Well, I prefer myself the 29-day cycle, simply because it lines up the Sun each time like this, and therefore it's timed with the phases of the Moon. There's a 29-day cycle. The tides on the Earth operate depending upon the moon, where the Moon is. That's on a 29-day cycle, and so on. So it's actually much more efficient to actually talk about the 29-day cycle rather than 27, because that's just the orbit, which is less important. Okay. Anyway, so at the same time, of course, the Earth's orbiting around the Sun, 365 days and 6 hours to orbit the Sun. You can't clearly have a 6-hour day, so what do? Ignore them. Okay, for 3 years is all you do. But of course, the 4th year, we add them together, 4 quarters, 4 sixes, 24 hours. So you get another day the 4th year. The leap year, of course. Okay, that's where it comes from. It does not mean it takes an extra day to go in the Sun during that year. All it really means we simply add up the 4 lots of 6 hours, or 4 quarters of a day, to end up with another day every 4th year. Okay, thank you.